Planning Operation Overlord, the D-Day invasion of Normandy, took 11 months. Thousands of officers across multiple Allied commands spent nearly a year coordinating logistics, modeling enemy positions, gaming out contingencies, sequencing the movement of troops and materiel across an ocean. The planning effort itself was arguably as complex as the operation. That was 1943. The limiting factor was human cognitive capacity, the speed at which trained military minds could process information, generate options, evaluate them against each other, and arrive at a plan with acceptable confidence. That limiting factor no longer applies. The United States Army has been testing and deploying AI systems capable of doing what a full general staff does: absorbing battlefield intelligence, modeling enemy positions and likely movements, generating and evaluating courses of action, sequencing operations across multiple domains simultaneously, in a fraction of the time any human planning process could achieve. Not in minutes instead of months, in seconds instead of hours. The systems involved have names: Project Convergence, JADC2, the Palantir Maven Smart System. They are operational. They have been tested in real military exercises against real adversary scenarios, and the results have fundamentally changed what military commanders believe is possible in the planning and execution of modern warfare. To understand what AI changes, you first need to understand what military planning actually involves. A military operation is not a single event. It is a sequence of interdependent decisions made across time, terrain, and multiple combat arms simultaneously. Infantry, armor, artillery, air support, logistics, electronic warfare, cyber operations, each has its own timeline, its own resource constraints, its own dependencies on what every other element is doing. Planning an offensive means modeling all of that simultaneously. Where is the enemy? Where are they likely to move if attacked from the west versus the north? What happens to the logistical chain if the primary bridge is destroyed on day 2? If air superiority is contested, which ground objectives become unreachable? What are the second and third order effects of each course of action? Human planners work through this sequentially. One course of action evaluated, then another, then another. The process is bounded by time, by the cognitive limits of the staff, and by the sheer volume of variables that must be tracked simultaneously. Military doctrine acknowledges this explicitly. No plan survives first contact with the enemy because the plan was built on incomplete information processed by minds with finite capacity. AI planning systems do not work sequentially. They evaluate all courses of action in parallel, across all variables, simultaneously. And they do it in the time it takes a human planner to pour a second cup of coffee. The clearest documented demonstration of AI-enabled military planning at operational scale is the U.S. Army's Project Convergence, a series of live experiments conducted annually since 2020 at Yuma Proving Ground in Arizona and later at Joint Base Lewis McChord. Project Convergence was designed to test what the Army calls multi-domain operations, the integration of ground forces, air forces, space assets, cyber capabilities, and electronic warfare into a single coordinated operational picture, with AI processing the combined sensor data and generating targeting and planning recommendations in near real time. The headline finding from the 2020 experiment was specific and stark. The time required to move from detecting a target to executing a strike, the sensor-to-shooter timeline, was reduced from 20 minutes under traditional planning processes to under 20 seconds using the AI-enabled system. 20 minutes to 20 seconds. A compression of 94% in the time available for human deliberation between the moment intelligence arrives and the moment a weapon is authorized. The 2021 and 2022 experiments expanded the scope. More domains integrated, more simultaneous targets processed, coalition partner forces brought into the AI-enabled network. The trajectory was consistent across each iteration. More data processed faster, more options generated simultaneously, more of the planning and targeting chain automated. In 2022, the Army publicly described the goal as a system in which a commander could receive an AI-generated operational plan, complete with sequencing, resource allocation, contingency branches, and targeting recommendations, within seconds of the intelligence that prompted it. Not a draft to be refined over days, a complete executable plan, ready for approval. Project Convergence is the Army's component of a larger architecture. The broader program is called JADC2, Joint All-Domain Command and Control. JADC2 is the U.S. military's effort to connect every sensor and every shooter across every domain, land, sea, air, space, and cyber, into a single integrated network, with AI processing the combined picture and generating recommendations across all of them simultaneously. The scale of what JADC2 is designed to integrate is difficult to convey. Satellites, ground radar stations, fighter aircraft sensors, ship-based sonar and radar, cyber monitoring systems, special operations field reports, drone surveillance feeds, intelligence intercepts, all of it flowing into a common operating picture in real time, with AI identifying patterns, flagging threats, and generating courses of action across all domains at once. The human commander at the center of this network is not evaluating raw data. They are evaluating AI-generated summaries, AI-ranked options, and AI-recommended sequences. The decision is formally theirs. But the information environment in which that decision is made, the options presented, the priorities surfaced, the timelines compressed, is constructed entirely by the AI. Military analysts and ethicists have a specific term for what this creates: automation bias. When a human decision-maker receives a sophisticated AI recommendation under time pressure, the cognitive tendency is to accept the recommendation rather than independently evaluate it. The faster the operational tempo, the less time between the AI's output and the moment action must be taken, the stronger that bias becomes. JADC2 by design accelerates operational tempo. It compresses timelines. It reduces the interval between intelligence and action. Every design choice that makes the system faster also makes independent human evaluation of AI recommendations harder. The software layer making much of this operational is built by Palantir, the same company that replaced Google in Project Maven and that provides AI-assisted targeting analysis for multiple allied militaries. Palantir's Maven Smart System, the commercial successor to its original Maven contract, is an AI platform that ingests intelligence from multiple sources simultaneously, generates targeting packages, and presents commanders with a ranked set of options and recommended sequencing. It is currently deployed across U.S. Army units and has been used by Ukraine as part of Western military support. What distinguishes the Maven Smart System from the targeting AI discussed in previous videos is its scope. It is not optimized for a single targeting decision. It is designed to assist planning across an entire operational campaign, ingesting logistics data, weather, terrain analysis, enemy order of battle, and available friendly forces to generate and update a coherent operational plan continuously as conditions change. The system does not wait for a planning session. It plans continuously in the background, updating its recommendations every time new intelligence arrives. A commander who checks the system after an hour away from their terminal does not find the same plan they left. They find a plan that has already adapted to everything that happened in that hour. Military commanders and ethicists are increasingly concerned about a problem that the speed of AI planning creates by design. International humanitarian law requires that military commanders exercise genuine judgment before authorizing an attack. Proportionality must be assessed. Distinction between combatants and civilians must be evaluated. Precautionary measures must be considered. These are not checkbox requirements. They are substantive obligations that presuppose a commander with time, information, and cognitive space to think. When the sensor-to-shooter timeline is 20 seconds, there is no time for that deliberation. When the AI presents a complete targeting package, already assessed for military necessity, already ranked by priority, the commander's functional role is not evaluation. It is approval. This is the rubber stamp problem, the same dynamic documented inside Lavender, scaled to the entire operational planning level. Not 20 seconds per individual target. 20 seconds between the AI's strategic recommendation and the commander's authorization of an entire sequence of operations. The U.S. Army and Department of Defense have issued principles for responsible AI use in military contexts. Those principles include requirements for human judgment in targeting decisions. What they do not address is the structural tension between those requirements and a system architecture that compresses the time available for human judgment to the point where it cannot meaningfully occur. The videos in this channel have documented a progression: AI that generates targets, AI that analyzes battlefield data, AI that makes autonomous strike decisions, AI that coordinates swarms. What AI planning systems represent is something architecturally different from all of those. The previous systems operated at the tactical level: the individual strike, the individual target, the individual drone. Planning AI operates at the strategic level. It does not decide which person to strike. It decides which campaign to run, which objectives to prioritize, which sequence of operations to recommend. And it makes those decisions by modeling second and third-order effects across an entire theater of war in seconds. No human general staff has ever had that capability. The question it raises is not whether AI planning produces better military outcomes. In narrow operational terms, it almost certainly does. The question is what happens to the human process of deciding whether to go to war and how to conduct it when the friction that historically slowed those decisions disappears. Military planners have always known that faster planning creates faster escalation. A general who can generate and execute an operational plan in hours instead of weeks has less time and less structural pressure to consider alternatives, consult allies, or allow diplomacy to operate. AI planning systems do not create that pressure. They remove the friction that previously moderated it. Project Convergence, JADC2, and the Maven Smart System are operational today. They are not being tested in research environments. They are embedded in the planning and command structures of the world's most powerful military. And every major peer competitor, China, Russia, is building equivalent systems on parallel timelines with the same goal: compress the decision cycle, accelerate the sensor-to-shooter chain, remove the human bottleneck from military planning at every level where removing it produces an operational advantage. The next video asks the question that sits underneath all of this. If AI systems now generate targets, plan campaigns, coordinate strikes, and make autonomous lethal decisions, and if no government has yet agreed on a binding rule about any of it, what exactly is the legal status of every strike that AI has participated in? Who is responsible? And what happens the first time an AI-planned campaign produces a documented atrocity?